Hi, and welcome back to the Save It for Parts channel. Today we're making an automated foam dart sentry turret. Now the turret itself is kind of a stepping stone to learning more about stepper motors and automatic tracking. In the long term, I'd like to apply some of this automated tracking to things like my satellite tracking system, which right now is completely manual. I've also got this larger C-band satellite dish, which I'd like to be able to track things. That's going to need some very large actuators and relays and all kinds of electronics that I'm not too experienced with. So to get more practice on some of this, I'm going to start a little smaller. Now I am basing this on some things people have come up with online, so I'm copying a lot of code and copying some design. I'm going to make some of my own tweaks, and I'm going to try to work with some of the equipment and computer stuff that I already have around. So I've got the ever-growing pile of Raspberry Pi and Arduino stuff. I keep finding cheap ones at local surplus stores like Axeman. Got some other random stuff from my hoarded junk bins like a webcam and some power supplies and whatnot. And then since I am copying other people's designs, I've gone ahead and ordered some new parts from the internet. We've got some jumper cables here. We've got some Raspberry Pi accessories like voltage adapters and relays and some other stuff. And then we've got the guts of the operation here, which is this knockoff foam dart blaster. I picked up this particular dart blaster because it has a one-button firing operation. Although now that I see it, I believe it has a on-off switch that actually revs up these flywheels, and that's what actually propels the darts out. It's got this stupid little security set screw in there to keep you from opening the battery compartment, which is really a hassle. Construction on this is extremely cheap. I can already see a potential issue where these darts don't last very long. I think they're fun toys and pretty chewable. So I really only need 2 stepper motors for this project, but I went ahead and bought a 3-pack in case I need ones for something else in the future. And these are fairly beefy motors. I think this is an NMEA 17. It's a standard motor that's used in 3D printers and CNC machines and whatnot, and it seems like it should be able to hold up some weight. I was a little concerned watching the original video that this is supposed to support the entire project and rotate it freely, but I think it could probably handle it. If it's a little heavier, I might end up adding some casters around the base plate or something. Alright, this wouldn't be the Save It for Parts channel if we just bought all the materials online for this, so I'm going to do some upcycling, some creative reuse of junk I have lying around. In particular, I've got this little clock that came in a box of junk from an auction. There was some other stuff in the auction that I actually wanted. This was just thrown in there. This is apparently some commemorative clock for the development team of OpenDoc for Macintosh from 1995, and it probably says something philosophical about software development when some team put enough of their life and effort into this software that they got a commemorative clock for it, and then over a quarter of a century later nobody remembers this software, and their little award is being broken down to make autonomous weapon parts. Anyway, you guys don't come here for philosophy. This is just trash, and I'm going to make it into something cooler than trash. I didn't bother to buy fastening hardware for these stepper motors, but I've got enough bins of random screws and bolts and hardware that I've probably got enough that'll fit it. Alright, before we can put the dart thrower on the mount, we've got to open it up and connect some wires to the trigger and probably to the on-off switch here. What would be even easier, we could just keep this turned on, tape down the trigger, and connect the battery wires up to that relay on the Raspberry Pi. That way when these 2 wires are connected, it just fires up and starts shooting, and we only need 1 relay. So these 2 wires would be going to the relay, so when the Pi commands a firing, then it would connect these 2. So now I can mount the blaster into this thing. The only problem is the center of gravity is kind of somewhere here in this rotating component, so I'm going to have to build like a bracket that goes underneath and balances the thing kind of in the middle. Otherwise that motor is going to be working too hard to aim it up and down. If I try to mount the motor in here, the whole thing's just going to tip back. Got the stepper motor control hat. This was shipped in about the laziest way possible. They just threw it in another plastic bag and put a label on it, so I'm hoping it's not damaged. It is some assembly required here, so I just have to solder all the connectors onto it. I'm a little confused about how to wire these stepper motors. Well, there's not much for pinouts on the model I bought, but it is quiet enough to install in children. It doesn't help that I have no concept of how stepper motors work and have never used them before. Here's another pinout with a third kind of terminology. Alright, so after looking at 3 or 4 different pinouts, I think I have an equivalency for the colors. Not 100% sure if this is correct. So these little microscopic screw terminals are just terrible to work with. You think you have them screwed down, but as soon as you bump one of these wires, all the other wires just pop out again. So now I have to solder on the jumper wires for the trigger relay. I do feel like I'm getting a little better at soldering, or at least less bad at it. This is something that requires a lot more dexterity than I initially thought. My fingers are pretty fat, and I've had a lot of caffeine today, so all these little connections are pretty jerky. Alright, I've used some twist ties to try to organize my wiring, which means everything is pulled out of the screw terminals again because these screw terminals are terrible. So I have to redo that, and then at that point most of my wiring should be done. Alright, I've got a fresh operating system on the Raspberry Pi, and I've got that fired up. Now, I still don't own an HDMI monitor, so I'm using my little HDMI mini projector from my arcade system, and I basically just need this long enough to activate remote access through a terminal, so I don't actually need the local monitor for very long. Alright, I almost forgot I have to pre-adjust this little guy. This is the voltage converter that goes from 5 volt input up to 12 volt. So that's the dingus that lets you use a standard USB power supply to run those 12 volt stepper motors. Now I thought this was the adjustment screw, but I'm turning it and it's not doing anything. Okay, now it's going up. I guess it was just turned all the way counterclockwise. These little things sure are fiddly. You can turn it a couple cranks one way and it doesn't change, and then you just touch it and it jumps up again. When I try to plug in the step-up voltage converter to the battery bank, it just kind of flickers and the battery bank won't turn on. So something's shorted out somewhere. Alright, so this little bugger is now stuck at 7 volts and just will not adjust, so I don't know, these little screw adjustment things just seem like a scam. If I can find one that just goes from 5 to 12, I'm going to buy that and avoid this little blue piece of junk. Now at this point, again, I'm just copying other people's code, I'm following other people's instructions, and as usual, I will put links to all that stuff down below. So the original project that I'm copying is a little older, it's from 2015 or so, and it suggests that I install OpenCV 3 before going ahead with the turret software. I'm going to try installing OpenCV 4. I really shouldn't be using Python 2 since there's now Python 3, but the original programmer of this turret software made it in Python 2. They've never updated it to Python 3 that I can find. It seems like the main difference between Python 2 and Python 3 is there's just more parentheses in version 3. I think the main development of any programming language is more and more parentheses, so it just looks like you're doing something every time you come out with a new version. Alright, let's try this a different way. Since this is Linux, there are at least 43 different commands that all do the same thing, and sometimes one of them will work when the others don't. There's also this virtual environment thing that is supposedly good practice, but I'm only ever going to use this Pi for one thing and this OS install for one thing. Alright, well, it's running now. Well, the frame rate on this little webcam is really terrible, but at least it can see a cat. Alright, so I've got the turret software working. I've got it mostly upgraded to Python 3 now, just had to change a few things in there. I still am not getting the stepper motors to rotate. I guess I don't understand the wiring on these stepper motors. Let's see if we can get this thing to fire at least, because that's a completely different set of instructions. That's just going through the Pi's GPIO bus and then out through this little relay. Alright, we've got our motor hat hooked up to external 12 volt. We've got that hooked up to the rotation motor, and we're going to see if that will rotate. Now, I've got all these extra wires hanging off this. It is no longer self-contained, so it's probably not going to rotate very well, and it's not going to rotate very far before it starts running into those wires. And it is working, but it's actually slipping the bottom disc on here. And then it's not stopping rotation, so it's getting stuck somewhere. Now it's just kind of having a seizure here, so I don't know what I did to it. Alright, so I messed up and I got the wrong stepper motors. That's why I was having trouble with the wiring colors. These are the correct motors. The electrical rating on these is a little bit different. As you can see, the size is just slightly different. I believe this guy takes a little less amperage to turn, so it can be controlled a little more precisely with the board that I've got. So I'm going to go ahead and swap out the old ones, put everything back together, and see if it works better. I also have my new DC step-up transformer, or boost converter, since the last one died. Alright, so once again I've got my little voltage adapter here, and supposedly you can turn this little screw and change the output voltage from 5 volts all the way up to 12 volts. And no matter which way I turn it, it stays at 5 volts. This does nothing. As far as I can tell, this whole assembly here is just a scam. I don't know if this is a real one, a fake one, or if these are just garbage to start with. I've tried turning it a little, I've tried turning it a lot. It does nothing. So don't buy these things. I've gotten 2 of them, and as far as I can tell, they're just fakes. Alright, well the stepper motors are actually working now. Alright, so interactive mode works just fine. How about motion detection? And this whole thing is not a very fast or efficient process, and it's crashed. Okay, so video works fine in the interactive mode, just doesn't want to work in the CV mode. Okay, so this seems to be another issue between Python 3 versus Python 2. So we've gone into lines 283 and 284 of turret.py, and we've moved a parentheses, a closed parentheses, from here before the percent sign to the very end of the statement, because apparently Python 3 processes the entire line before doing the print. You can't do them in separate pieces. We've also changed line 158, which had an extraneous IM variable in this contours threshold hierarchy thing. So we've taken that out. Now it's just contours and hierarchy, so there's only 2 variables in that statement. And again, I don't actually know what I'm doing with the Python programming. I'm just Googling the errors and then seeing what the GitHub and Stack Overflow comments say to do. This is some very resource-intensive code, and if you do get it working, it might just lock up, or you might not be able to stop it again. So I'm actually trying to close my video window and my console screen here, and everything's locked up over VNC Viewer. So I might just have to reboot the Pi to get back into it. Let's try this again. And again, we've gotten rid of that entire virtual environment nonsense, because while it's probably good practice, I just want this to work, and it's way too much effort to get that working. Let's try automated motion detection this time. And we'll try the live video again. I think it's definitely overcorrecting for where I am. Well, it fired at where I was. Alright, so this thing does work. It's not 100% self-contained, because in automated mode the webcam has to sit out separate from the rotating part. And then I am still tethered to my 12-volt power for the little stepper motors, because my 12-volt step-up converters keep being fakes. It's still not super accurate, and it's definitely not quick response. So a target could definitely cross this thing's field of view fast enough that it never gets targeted or fired at. Even when I do this in a closed room, I still lose about 10% of my ammo per shot. It doesn't help that the cats find them fun. Apparently this is just a toy dispenser. Okay, so this thing works to an extent. It's not a fantastic Sentry turret, it's just too slow to really be practical in any way. Now, it has given me a little more experience with these stepper motors, with this control system, and with some of that AI tracking software. So hopefully I can apply this to things like satellite tracking antennas and other more interesting things in the future. Now, if I were going to use this as an actual Sentry turret, I could do a few more improvements. I could have the scripts auto-run when it starts up. I could switch from my wired 12-volt to an onboard 12-volt with the battery pack. And I could use something like a little IR remote to arm and disarm it when I walk into a room. I'm not going to do any of that. I'm kind of done with this project. It's been fun, I've learned some things, but I'm going to set it aside and work on something more interesting now. You may notice I skipped around a little bit, and I didn't fully explain what I was doing during the build or programming process. I actually got pretty sick while I was building this, and a lot of my voiceovers just didn't make sense, and I had a lot of false starts and a lot of wrong directions. So I don't really have good documentation of the entire thing. I do apologize for that. While my video here is not going to be a good how-to on how to make one of these, I will try to explain in the description of what things I modified from the original video, and I will link to that. So by following along with the original project and using some of my tweaks to the Python code, you should be able to use this with Python 3, with OpenCV 4. Well, I might keep this thing around in a box for a while, but I suspect I'm going to be salvaging these components for some other project. The Raspberry Pi can be used for something else. The motor hat can be used for something else. The battery pack, we may or may not pull this out again, or we may just scavenge it for parts, as is the theme of the channel. I hope you've enjoyed this impractical but fun project as much as I have. Thanks for watching, and we'll see you next time.